In this video, I want to have a look at something called conditional probability. So in our last video, we had a look at dependent and independent events, and conditional probability has to do with dependent events. So when we have dependent events, we can be asked to calculate the probability of one event given that another event has already occurred. So we're saying, given that this particular outcome happened in the first stage of our experiment, what's the probabilities of something in particular happening in the second stage? So for example, we've got a bag that contains 3 red marbles and 2 yellow marbles. We're going to draw 2 marbles from the bag at random without replacement. It's asking us what is the probability that the second marble is yellow given that the first marble was also yellow. So if we know that the first marble was yellow, so we can write the first was yellow. That means that what we have left in the bag is we're still going to have 3 red, but we're only going to have 1 yellow left. So given that we know this happened, we can look at the probability, we can look at what's left over, and we can figure out the probability that the second marble will also be yellow, which would just be, so the probability of yellow, would just be 1 out of 4, because there's 4 marbles left, and only 1 of them is yellow. All right, our second example says 2 dice are rolled and their total is calculated. Use a table to show all possible values. So we're looking at the sum. I'm going to draw this down here, and I'm going to draw my first die across the top and the second one down the side, and then write in all of their sums. Okay, so I've got my table there, so this is all the possible sums. So there's 36 outcomes in our sample space. So given that the total is 7, what is the probability that one of the dice shows a 3? So given that the total is 7, so that means we're only looking at these 6 possible outcomes. So our sample space has just been reduced to these 6. So our denominator in this probability is going to be a 6. Given that the total is 7, what is the probability that one of the dice shows a 3? So for all of these, this one came from a 6 and a 1, so that's not what we want. This one came from a 5 and a 2. This one had a 3 and a 4, so that one's one that we want. This one had a 3 and a 4 as well, so these 2 so far. This one was a 2 and a 5, and this one was a 6 and a 1. So we've got 2 out of the 6 of those that involved a 3, which will simplify down to 1/3. All right, question C. Given that one of the dice shows a 4, what is the probability that the total is 10? So given that one of the dice shows a 4, so we want this column and this row, but this one, we don't want to count it twice because we just counted it when we went down. So there would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 possible outcomes. And we want what is the probability that the total is 10. So there's 2 of those. There's 1 here and there's 1 here. So the probability that it's going to give a total of 10 would be 2 out of 11. All right, question D. Given that the total is 6, what is the probability of a double? So the total is 6 is 1, 2, 3, 4, 5. So there's 5 possible options. And the only one where that occurs because there's a double is at 3, 3. So that would be 1 out of 5. Right, given that a double is rolled, what is the probability of a total of 12? So a double being rolled is a 1, 1, a 2, 2, for example. So it's this diagonal down here. So there's 6 numbers there. The probability of it being 12 is only going to be 1 of those. So 1 out of 6. And given that a double is rolled, so we're still going to be out of 6. But we want that there's going to be a total less than 10. So we don't want the 12 or the 10, but we do care about the 2, 4, 6, and 8. So that's going to be 4 out of the 6 of them, which would be 2/3. So that's having a look at conditional probability.